Slide 1. Leeds International School Mathura. Subject Mathematics. Form 4. Term 3 Midterm. Text International GCSE 9-1. Alan Smith and Sophie Goldie for Edexcel Specification 8. Pythagoras photograph, and below there are two short descriptions about Pythagoras. Slide number 2, chapter 15, page 276, Pythagoras Theorem. In this chapter, you will learn how to use Pythagoras theorem to test whether triangles are right angled. Number 2, using a Pythagoras theorem to find out an unknown side in a right angle triangle. Section 15.1, page 277, introducing Pythagoras theorem. Pythagoras theorem concerns right angle triangles. Slide number 3. In figure 1, AB equals C hypotenuse, B equals opposite side, A equals adjacent side. Note, opposite and adjacent sides for future trigonometry purposes. In figure 2, Pythagoras theorem states that C squared equals A squared plus B squared, that is 13 squared equals 5 squared plus 12 squared. Slide number 4. Note, there are many ways of proving Pythagoras theorem, and you have to keep in mind that the theorem works only for right angle triangles. Pythagoras theorem can be used to check whether the triangle is right angled or not. The following are two examples. In figure 1, the triangle ABC, the longest side is C. In figure 2, triangle A1, B1, C1, the longest side is C1. Slide number 5. So, C equals 12 centimeters, A equals 6 centimeters, and B equals 10 centimeters in figure 1. Then, C squared equals A squared plus B squared, that is 12 squared equals 6 squared plus 10 squared. So, 144 is not equal to 36 plus 100. Therefore, triangle 1 cannot be a right angle triangle. In figure 2, C1 equals 13 centimeters, A1 equals 5 centimeters, B1 equals 12 centimeters, then C1 squared equals A1 squared plus B1 squared, that is 13 squared equals 5 squared plus 12 squared, so 169 equals 169. Therefore, triangle 2 must be a right angle triangle. Exercises. For each of the triangles described below, use the Pythagoras theorem to decide whether the triangle is a right angle triangle. If so, name the angle at which the right angle is located. Page 278, question number 4, question number 6, question number 8, and question number 10. Section 15.2, using the Pythagoras theorem to find the hypotenuse, the longest side. Note, In this section, we shall be working with right angled triangles and will use Pythagoras theorem to find the hypotenuse. Longest side is the side opposite to the right angle, which is the hypotenuse. Slide number 6. Exercise 15.2, question number 7. In the right angle triangle above ABC, find the longest side BA, which is equals to C, which is equals to the hypotenuse. Find the answer to three significant figures. Pythagoras tells us that C squared equals 2.1 squared plus 1.8 squared. Therefore, C equals square root 2.1 squared plus 1.8 squared, which is approximately equal to 2.7658 equals to 2.77 meters to three significant figures. Slide number 7. Note, this type of calculation, answer is not a whole number. Therefore, the types of answers can be simplified to 1. Significant figures, 2. Decimal points, 3. Nearest whole number to nearest 10 or to the nearest 100, etc. In some calculation, distances can give it in different units. So, the first convert into same units. Example below. In triangle XYZ, XZ equals 13 centimeters, XY equals 50 millimeters, YZ equals 120 millimeters. Exercise 15.2, question number 10 and 11, page 280. Section 15.3, slide 8. Using Pythagoras theorem to find one of the shorter sides, page 208. The method used above may be adapted when the unknown side is not the hypotenuse. In this case, the calculation requires a subtraction instead of an addition as shown in the example below. Exercise 15.3, page 281, question 9. Find the value of the right angle triangle as shown in the figure 1. Slide number 9. By Pythagoras, 3 squared equals a squared plus 2 squared. Rearranging, a squared equals 3 squared minus 2 squared, which is equals to 9 minus 4 equals 5. Therefore, a equals square root 5, which is equals to 2.236067977. Therefore, a equals 2.24 centimeters to three significant figures. Exercises. Exercise 15.3, page 281, question numbers, question 6, question 10 and question 11.